Hi, my name is Anirudh Phadke, and we would be discussing the concepts of divisibility rules today, which have immense implications on how you solve problems in number systems. So let's start with our discussion on divisibility rules. So let's try and figure out what are the divisibility rules and how do you derive these divisibility rules. That would actually make you understand how divisibility rules are framed. And one of the most interesting rules that we have is the rule by 3. So how do you figure out whether a number is divisible by 3 or not? It's quite similar to the divisibility rule for 9 as well. So let's try and see an example. For instance, if I have a number 7, 4, 8, 9, 5, just a random number, and I want to check whether this number is divisible by 3 or not. So I would add all of these digits. Now while adding, there is something that you could also make it easier to add, and instead of adding all of them together, you can actually eliminate 9s in the addition. So in fact, you don't really need to add 9 because we work in the decimal system, and because of the decimal system, the addition of 9 doesn't really matter in the final addition. So 9, here you see 9, there is another 9 that we can form from 5 and 4, so you can ignore that as well. So you're left with 7 and 8, so 7 plus 8 is 15, and I know that 15 is a multiple of 3, but I can still continue doing the addition. And I can say 1 plus 5 is 6, and of course 6 is a multiple of 3. So this entire number is going to be a multiple of 3. Obviously, if I change this 5 to 4, this would have definitely not be a multiple of 3. So what are we trying to do here? Now, as I said, it's important to understand how to derive this relation, how to derive this rule. And for that, I think it's important to also understand place values concept. So let's try and do a bit of math here. Maybe we can take a smaller number, say 748. And I can write this as 8 plus 40 plus 700. And obviously I can also write this as 8 times 1, I can write this as 4 times 10, and this as 7 times 100. Now the important point is, when I write it like this, and I want to figure out what is the ultimate remainder, or whether it is divisible by 3 or not, I can actually check for individual remainders and then keep adding them together. So let's try and do that. What if I divide 1 by 3? What is the remainder that I get? Obviously, I get a remainder of 1. So my remainder will be 1. So let me write down all the remainders here. So if I divide 1 by 3, I get a remainder of 1. From 10, I get a remainder of 1 again. And from 100, 3 times 33 is 99. And I again get a remainder of 1. Now the important point is, if I were to write this only the remainders form, so 8 times the remainder of 1, that is 1, plus 4 times remainder of 10, the remainder of 10 was 1, plus 7 times remainder of 100, that is again 1. Obviously I don't need to consider this one, and this one, because anything you multiply by 1 is actually the same number. So this derives itself to 8 plus 4 plus 7, and this is exactly the same thing that you'd done here. You know, when I wanted to find out whether this number is divisible by 3 or not, what I did was I added 7 plus 4 plus 8, and that's what I've done here, in the reverse fashion, of course, because we have written it in the other way. So this is how you derive this rule of divisibility by 3. Now you can also understand that this same rule would be 1. 10 divided by 9 again gives you a remainder of 1. 100 divided by 9 9 times 11 is 99, and that would also give you a remainder of 1. So that's how the remainders, the divisibility rules are derived. The beauty of this rule is that you can actually use it to find the remainders as well, not just the divisibility, because if I change this 5 to, let's say, 6, then my remainder would be 1, because till 5 it was an exact multiple of 3, and now because I've added 1 to it, so my remainder would be 1 instead of 0. Okay, so in the next session we are going to do more on divisibility rule by 11, and that's how things would get more interesting. Thank you for watching.